Hello, everyone. Welcome to this foundational course in computer science, computing systems, and the act of programming. So basically, in this course, you're going to be given the foundation that you need to have a good career in tech. Okay, so most of the things that we do in tech, AI engineering, data analysis, software development, mobile development, web development, whatever it is, cyber security. Now, the thing is this: if you do not have a good understanding of computer science, if you don't have a good understanding of how the computer works, it's going to be difficult. Because for me, I come from a background of I read biochemistry. I didn't do computer science. Okay. But when I found interest in in computer programming, software development, I started learning and things were kind of awkward for me. But by the time I did a course like this, a foundational course like this, everything started making sense. Everything started making sense. So it is like a medical doctor who doesn't understand the anatomy of his patients. Okay, for you to be a very good medical doctor, you need to understand anatomy of the body. All right. For you to be a medical doctor, you need to understand biology, you need to understand chemistry. So without these two things, it's going to be difficult. And most especially, you need to understand the anatomy of the body. So what we are going to be doing in this course is giving you the anatomy of the body. Okay, see yourself as a medical doctor, and we are just trying to make you understand how the body. Okay, so here we are going to make you understand how computer science works, how computing system works, what are computing devices, what they look like, the act of computer programming. You're going to understand how computer science works, how computer is built, and stuff like that. Okay, so basically, this will be more of discussion. These few chapters, okay, is going to be more of we are going to be discussing. It's going to be more of theory, okay, until we now get down to computer programming. All right. So now this is not going to be difficult. I promise you that, okay? All you have to do is to pay attention. And for any reason you don't understand something, please always reach out to us, okay? Make sure you write your test. Make sure you do your assignment. This is really going to help you. So this is a foundational course that you need to build a very good career in tech, okay? So without further ado, let's jump into it. So, let's define computer science, okay? And let's also understand the scope of computer science. What exactly can computer science actually do? Okay, so let's understand the definition. Then we'll understand the scope, okay? What is the domain? Okay, what is the reach of computer science? So basically, computer science is just the study of computation, automation, and information. I believe the first time you heard about computer, okay, they told you that a computer is a machine, a device that takes in data, processes data, and gives you an output. Okay, so basically that thing is computation. Okay, with computer or in computer science, we are doing more of computation. Okay, we are taking data and we perform some operations on that data. Do you understand it? So basically, what a computer does is that it takes data, you give it data. It's either you type in something, okay, you give computer data, all right, and your computer will make some computations to perform some operations on that data that you gave it, then gives you output. And most times when this data is being processed, you get information, and some of these things can be automated. Okay, so basically computer science is the study of computation, automation, and information. Okay, there are more definitions that we can get when it comes to computer science. Okay, now it focuses on designing algorithms. Okay, now when you want to perform an operation on data, okay, remember basically what computer does is that it takes data, you give it data, it will make do some computation on that data and give you the result. Okay, so now before the computation is done, before the operation is done on that data, all right, there's something we call algorithms. Okay, algorithm is just, although we will still talk more about it, but it's basically what are the steps am I going to follow to perform this computation? Do you understand? Okay, remember, computer does computation. It performs operations on data you give it. Imagine when you take your phone now, you want to talk to AI. Maybe you say something to AI, maybe voice recognition or something like that. You actually, when you say something to the AI, you're actually giving it data. So when you voice into, maybe make a sound or voice into that AI. The AI will not take that voice, that sound that you gave it, do some operations on it, perform some computations, and then process it and give you the output. So what are the steps by step procedure to follow? That is what algorithm is. So when we talk about computer science, we are designing algorithms, okay? What are the steps that we need to follow to perform this operation on this data? All right. So algorithm, will still come to that, but it's actually step-by-step procedure to do something. What are the steps am I going to follow to perform this operation? Okay. So it also focuses on developing software and systems. All right. It focuses on developing software and system. Basically, you cannot do anything without it. For now, the computer is basically a hardware. Okay, it's hardware. But the thing is this: the computer will need a software, all right, to perform those things that you want it to perform. All right. So developing software and developing systems. Okay, that's computer science focuses on designing algorithms and developing software and systems. And basically, as a software developer, in case you choose to go into software development or software engineering, you'll be developing software. And software is just a set of instructions you give the computer to do something for you. Just like now, when you take an AI agent, or maybe you have an AI app on your mobile phone, okay, that's a software. Okay, whoever developed that software has written set of instructions that the computer has to follow when you tell the AI something. Okay, let's say you're using ChatGPT now. Okay, when you type in something on ChatGPT, or you make a voice note to ChatGPT. The ChatGPT is a software. Okay, now the developer of that ChatGPT has given the computer a set of instructions to follow. Okay, so in computer science, we focus on developing software and systems. We focus on analyzing data. Okay, when it comes to people who data analysts, okay, they take in data and they analyze it. So computer analyzes the data you give it. Okay, so your computer can also analyze. Computer science also focuses on analyzing data and also understanding the theoretical foundations of information processing. I know this might be a lot. Okay, I'm trying my best to explain the much I can, but this is not really hard as you take it, okay? Basically, computer science is just the study of computation, automation, and information. There are more definitions that we can also see later, but it focuses on designing algorithms. What are the step-by-step procedure to follow to perform a computation? Okay, it also focuses on developing software. So computer will take instructions from you. So a developer is somebody who gives computer set of instructions to follow. And those set of instructions is what we call a software. All right. It also focuses on analyzing data. When you give software your computer data, it can also analyze it. All right. So it analyzes data, and it also focuses on understanding the theoretical foundation of information processing. And at its core, computer science blends with mathematical logic. Okay. It blends with engineering principles and also problem-solving techniques. Okay. Now, these are basically three principles. As in, computer science borrows or makes use of principles from mathematics, from engineering, and problem-solving techniques. Okay. So with this three things, it can build efficient, reliable, and secure computing systems. Right. So basically, computer science blends, okay, with mathematical logic, engineering principles, and problem-solving techniques. All right. So, but it doesn't mean that if you're not good in mathematics, that you cannot do well in any of these tech courses, or maybe you cannot do well in computer science. No. All right, it's not pure mathematics, okay, but it borrows mathematical logic, okay, engineering principles, and also some other problem-solving techniques, okay. So it enables the development of technologies, all right. When you're studying computer science, okay, all right, computer science enables the development of technologies that power everything from smartphones and websites to artificial intelligence and space exploration. Computer science has a lot to offer, all right? There is a lot. So we're also going to be exploring the areas and also going to be exploring the domains of computer science. Computer science is just a lot, okay? So, but since you want to make a career in tech, you can just focus on one of these areas, okay? You don't one of these domains. I'm a software developer. That's my specialization, okay? So, but you can specialize in maybe data analysis, cybersecurity. There is just a lot, okay? So the scope of computer science is broad and is and constantly evolving. Now, the scope that we have now might not be what we're going to have in the next 10 years or next 20 years. Before 10, 20 years back, all right, we didn't have this 30 years or 40 years ago, we didn't have artificial intelligence. Okay, but now we have artificial intelligence, okay, and we have a data analysis and a whole lot coming. 10 years before now, we didn't have cloud computing, or even 20 years before now, we didn't have cloud computing. But right now, we can do so many things in the cloud, okay? So there are computer science, the scope of computer science is actually very, very broad. Okay, it includes areas such as computer programming and software development. Okay, it algorithms and data structures. Okay, computer architecture and operating systems. Now, these are areas you can actually specialize in. Artificial intelligence and machine learning. Okay, what your ChatGPT it does is artificial intelligence and machine learning. Okay, and then cybersecurity, networking and databases. Now, human-computer interaction. This human-computer interaction has to do with people who design how people can interact with the computer. Because right now on your mobile phone, you're actually clicking on some icons. Clicking on those icons, you're actually interacting with the computer. So there are different areas the scope is very, very broad and it is evolving. And that is why we are telling you that there is something for you here. The industry is big and it's growing so big. Okay. Now, when you have a career in tech, you don't look for a job. You're not going to be job hunting. There are a lot of jobs out there waiting for you because this industry is big. It's very, very broad. We will also have data science and cloud computing. There is just a whole lot of domains that you can actually pick one and focus on. Now, computer science is also highly interdisciplinary. Okay. Now, it has a whole lot. It is highly interdisciplinary and it impacts fields such as healthcare, all right, finance. These are areas where you need computer science. Healthcare these days cannot operate functionally without computers. Okay, finance cannot operate functionally without computers. Agriculture, education, entertainment. Now, these are areas. Now, it doesn't matter if you're studying medicine and surgery, you can still have this knowledge because you need it. Okay, you're studying optometry, you're studying nursing, you're studying economics, you're studying banking and finance. Whatever you're studying agriculture, you're studying education. You need this. Okay, it is something that if you have this skill, if you have this knowledge about computer science, you have a skill, maybe data analysis, or whatever it is that you're going to actually venture into or specialize in, it's not going to be a waste. Okay, if you're into agriculture, computer science can also be used there. Okay, so as technology becomes more integrated into everyday life, because these days there's no way you do without computer. There's no way. Every day you're pressing your phone. Every day you're on Instagram. Every day you're making transactions. You're buying. You're selling. These things cannot be possible without computer science. It cannot be because these days, in our everyday life, we make use of computer. Okay, so the relevance and applications of computer science continue to expand and making it a foundational pillar of the digital age. In this digital age, you cannot do without a computer. So it is better, it makes more sense that you understand computer science. Okay, in short, we are even trying to push it so that every student in even secondary school students now take these courses. They understand these things very well now. Secondary school students, okay, it has been incorporated into their curriculum. All right, so let alone university students. So these are the things that should be in your GSTs. These are the things that should be incorporated in your GSTs. Okay. So now let's have a better look at the definition of computer science. Okay. So computer science is the systematic study of computers and computational systems. All right, including the theory, the design, the development, and application. So in computer science, what are we doing? We are systematically studying computers. We are understanding computational systems, all right? And this includes the theory, the design and development and applications of these systems, all right? So it focuses on how to process store, communicate, and manipulate information efficiently and securely using computational methods. It's just so broad that we just have to. Now, let's take a look at some popular definition. According to Association for Computing Machinery, all right, they said that computer science is the study of algorithms. Remember, algorithm is just your step-by-step procedures that you follow to do a computation or process data, okay, or perform some operations on data. Algorithm is just like your recipe, all right? You have recipe for cooking jollof rice, you have recipe for cooking afan soup, you have recipe for cooking or doing so many things. So algorithm is just like recipe, but don't worry, we're going to get into more details into algorithm because it's actually huge when it comes to computer science. So we'll discuss that in details, okay? So it is the science of the study of algorithms and data structures. Now, what are data structures? Of course, we make use of data. Whenever we are dealing with computers, okay, we are making use of data. You give computer data to process for you. After processing it, it will give you a result. So those data, all right, data structures are the things that we use to store data. It's like containers. Data structures are containers for storing data. So there are different containers for storing different data. And there is a particular container that is designed to store a particular data efficiently. Don't worry, we are going to talk about algorithms and data structures, okay? Then we also talk about their design, their implementation, and their application, okay? So Oxford Dictionary defines computer science as the study of the principles and use of computers. So basically, when you're studying computer science or when you're taking a course like this, you're basically going to understand how computers work, how computers process data. When you give them data, how do they process this data? Okay, and after processing this data, how do they give it to you back? So there's just a whole lot to learn here. Trust me, it's going to be very fun. Okay, now what are the key concepts of computer science? Now you need to understand these things, okay? The key concepts of computer science is number one, problem solving. Basically, computers were designed to solve problems. And look around you. Any computing device that you have, whether it's your mobile phone, whether it's your laptop or your desktop, what your computer does is solving problems for you. All right? So, and these are the key concepts. Problem solving with algorithms. Computer science has to do with problem solving and with algorithms. Okay? It also has to do with designing and analyzing software and hardware. All right? These are the key concepts of computer science. Problem solving with algorithms, designing and analyzing software and hardware. Okay? Understanding computation. Basically, computation is just the operations that the computer performs on those data that you give the computer. So one of the key concepts of computer science is understanding computation in both abstract and practical terms. We will also talk about what we mean by abstract, okay? We call it abstraction. We'll still talk about it, okay? So abstract, when we say something is abstract, we are basically hiding some information from you, okay? So understanding computation in both abstract and practical terms, okay? Don't worry, we're still going to talk about this abstract that we just mentioned here. We are going to explain it better because we'll still talk about abstraction. That's one of the key, one of the recurring themes when it comes to computer science is something that you have to understand because computer science makes use of faith often, okay? So what is the nature of computer science? It is theoretical and practical, all right? In the sense that it combines abstract theory, mathematical logic, computational theory, they are abstract. We don't really see them. We don't really touch them. So it combines abstract theory with hands-on skills, okay? So these mathematical logics, all right, we don't see them. Computational theories, it's not something we see. They are very, very abstract. But the thing is that we can bring it to life with hands-on skills like coding and debugging, okay? I might have an idea now, all right? And I can just write a program and tell the computer what to do for me. I might have a mathematical logic. I want the computer to perform for me, or I have a computational thing I want the computer to perform for me. But now I will have to make it more practical by writing some code. That's what we mean by coding, okay? So it combines theoretical and practical aspects, okay? So computer science is theoretical and also very practical, all right? And in the first few chapters of this course, we'll be talking mostly about the theory, all right? And later on, we'll now start talking about coding. When we start talking about programming in C, programming in C++, and also programming in Python, okay? So it is interdisciplinary, okay, in the sense that it overlaps with so many fields, all right? When it comes to computer science, we are talking about mathematics, we are talking about engineering, psychology, biology, and linguistics, all right? So computer science is interdisciplinary in the sense that it overlaps with this kind of fields, the mathematics, the engineering, psychology, biology, and linguistics. It is also problem-oriented, okay? Computer science is driven by the need to solve real-world problems using computational techniques. So basically, computer science is just about developing solutions to problems, and you can see that. Okay, everything about computer science that we do around us, everything about our phones, our computing devices, okay, they are there to solve problems for us. Okay, so computer science is problem-oriented, all right? It looks at solving problems, real-world problems, all right? So what is the scope of computer science? The scope of computer science is very vast, and it is rapidly expanding. It includes all areas where computation, data processing, and automation can be applied, okay? Computation, data processing, and automation, this is the key concept. These are the key concepts of computer science. All right, anywhere you can apply computation, anywhere you need to compute something, anywhere you need to perform operations, anywhere you need to perform some data processing or automation, you need computer science in that area. All right, so what are the core domains? We look at algorithms and data structures, okay? We look at, now these algorithms and data structure, like I have already told you, algorithm is the step-by-step, all right, procedure to solve a problem. So when we talk about algorithm, we are designing step-by-step solutions, okay? So don't worry, we're going to see more on these algorithms later on in the course. All right, examples is like, how do we sort a particular data? Let's say you have some data. How do you sort this data? Okay, how do you sort this data? How do you do some searching? Okay, so core domains also include programming languages, because if you want to talk to the computer, you need to speak the language of the computer. All right, so computer only understand its own language. So if you want to talk to the computer, you actually have to use programming languages. And this involves the syntax and the semantics of writing code. You know, most times when you see us write some code, it is very cryptic. You don't really understand it. That is why it is called code. Somebody will say you're talking in code. All right. So when it comes to computer programming, we are writing some code. It's only computer that understands it. So computer languages like Python, C++, Java, these are languages used to talk to the computer. All right. So core domains also include the computer architecture. So when we talk about computer architecture, we are talking of how is this computer made? What is it's like the anatomy. Okay, computer architecture is like the anatomy of the computer. All right. What is this computer made of? How was this computer made? What are the key parts of this computer? So internal hardware and how instructions are executed. These are the things. We're still going to learn computer architecture. All right. The CPU, the memory, and the I/O devices. How do these things work? We also talk about operating system. This is one of the core domains of computer science. Okay. The operating system is also a software that manages hardware and software resources. We'll talk about it in later chapters. All right. So software engineering is also another domain, all right? Building reliable and maintainable software. Software engineering is the aspect of engineering that actually governs the principles or how we are supposed to build a reliable and maintainable software, all right? So project management, testing, and documentation of software. We also talk about databases as a core domain, because basically when you are working with data, you would want to store this data somewhere, all right, so that you can actually make use of it later on. So databases, these are the things we're also going to be discussing in this course, okay? Artificial intelligence and machine learning, it is something we're not going to be discussing in this course, but the thing is that we have another course where if you want to become an artificial intelligence engineer or machine learning engineer, we actually have a course for it. Okay, so cybersecurity is another thing. When you're protecting your data over the internet, okay, cybersecurity has to do with protecting data over the internet. How secure is your data over the internet, okay? Encryption, authentication, and malware defenses, okay? So human-computer interaction, like I have told you, has to do with the interfaces. Okay, how do we interact with the computer? So we design usable and accessible system using the human-computer interaction, user experience, and UI design. All right. So another domain of computer science is theory of computation. Okay. So here you need to understand what problems can be solved by computers. Basically, it's not all problems that can be solved by computers. So with the theory of computation, we need to understand what problems can be solved by computers. We also talk about the automata, the Turing machines, and complexity. Now, this can be a lot, but computer science is just amazing. Okay, we'll take it step by step. All right, we'll just take things step by step. So, what are the applied areas? All right, most of these things are going to get, you're going to understand them better as we go on. Okay, so where do you apply? Where can you apply computer science? You can apply computer science in web and mobile development. Okay, you can apply it building online platforms and apps. This platform that you're using to learn is an online platform, so it's a web application. All right. So we also have the cloud and distributed computing. What we mean by cloud and distributed computing is that you can be operating, you can be in a local place and you'll be operating or working with a computer that is not with you over the internet. Okay, more of that will be coming on later. Okay, so data science and big data. All right, so these are places you can apply computer science. You can apply computer science, robotics. Okay, so these are huge areas where computer science can be applied. All right. You can also apply computer science when to computer graphics and visualization. Most of us are familiar with things like this. Bioinformatics, where we use CS in genetic. Now, this is basically maybe when it talks of health or biology, okay? Blockchain and cryptography, okay? So these are areas you can apply computer science. So the importance of the scope. Let's take a look at the importance of the scope of computer science. And we already see that the scope of computer science is very big. So first one is versatility. All right, computer science applies to nearly every industry. So whatever course you think you're studying right now, computer science is needed. All right, whatever course you're studying. So if you're studying management or a business management, computer science is needed. If you're studying any health-related course, medicine and surgery, nursing, whatever it is needed. Banking and finance, economics, computer is needed. So you can also learn this. All right, you can be a developer and develop some applications that can be used in your particular field. Okay. We can also look at it, innovation driver. It enables the development of new tools, apps, and platforms. Computer science is just crazy and it's just getting bigger. The job market, there is high demand for computer science professionals globally. There is high demand because the industry is blowing up. Okay, the industry is blowing up down. I don't think that with the rate of the growth of the industry, it is not, we developers have not really matched, okay, the growth of the industry. So you also apply in problem solving. We have already seen things like this. So this is very huge. All right, real world applications like health, all right, AI diagnostics, electronic records, finance, online banking, fraud detection, you see agriculture. These are the places you can apply computer science. Crop monitoring, smart irrigation, education, e-learning platforms, there is a lot. All right, security, all right, transportation, self-driving cars, GPS systems. Okay, so what are the key characteristics of computer science? Abstraction. We are going to talk about this abstraction in a separate section where we'll discuss it in details. But basically, you don't need to understand all the details about something. So sometimes there are hidden details to simplify problems. All right. Just like now, you're using the computer, but you don't know the internal structure of the computer. You don't need to know it. All right. All you have to do is to know how to click on icons and perform some operations that your mobile app or your laptop can process. Okay, so we are going to talk about abstraction in its own section and we'll discuss it in details. Okay, automation, you use machines to perform repetitive tasks. Most of these times we don't even need to perform things manually anymore. Efficiency, solving problems using the least time and resources. Computer science can solve problems using the least time and resources, and that's why you see most employers now are using computers. because computers can work better than human beings, okay? So they solve problems using least time and resources. Modularity, they break a large system can be broken down into small manageable parts. These are the things we are going to be taking a look at as we go on, especially when we start coding and developing applications. So these are the key characteristics of computer science. Scalability, okay, you can design a system that can grow over time. All right, as the need grows, the computer can the systems can grow. All right, so it's called scalability. You can scale it. You can start a system very small, but as the user needs increase, you can also increase or grow your system. Okay, so let me mention key terms that you need to remember. You see, algorithm is something that you must remember. You're going to make use of it. You're going to do a lot with algorithm. We have a separate chapter for it. Okay, now program is a written set of instructions for a computer. All right, all those icons that you're clicking on your when you click the icon for Facebook or click the icon for TikTok, those things are programs, they are software, okay? So these are written set of instructions for a computer. Data is raw facts or figures for processing, all right? But information is when this data has been processed. Data is a raw fact, you have not processed it, but information is a processed and meaningful data. Hardware has to do with the physical parts of a computer. Now, we also have software, which is not you cannot see software, okay? You cannot see a software. So hardware, you can see it, but software, you cannot see it. So there are instructions that run on hardware. A program and also a software can be interchanged, okay? You can say a program is a software because both of them are the same thing. They are all written instructions, all right, that are performed by the computer, but these instructions are run by the hardware. Don't worry, when we talk about hardware versus software, you're going to understand more about this, okay? So now, how much do computer science professionals make? All right, the mean entry-level salary for computer programmers is $64,000 according to payscale.com. And I want to give you an assignment. All right, I want you to go and make research on this. Go and do a thorough research on this. How much do computer science or computer programmers or tech people, how much do they earn? Go and make research on your own. Okay, $64,000 per year. Imagine you earning such thing. Yeah, and you can earn up to 100 or 200 depending. Now, this is a career that is worth it. All right, in the next 2 years, 3 years, 4 years, you can build a solid career that can be paying you over $50,000 every year. That's in Nigeria, that's over $70,000. Okay, so that's over 70 million naira. In Nigeria, it's over 70 million naira. Just imagine it. So this is a career that is worth building on. Why the highest 10% can earn up to $162,000 to 200,000. Google pays up to $1 billion a year. $1 million, sorry, $1 million a year. But it actually depends on your level. But what I'm trying to say is that it is a career that is worth building. In the next 5 to 10 years, in the next 20 years, you can build a formidable career that you'll be proud of. Your family will not be hungry again. You will have a lot of money to invest and build other things that can also be bringing you money. So this is really worth it, okay? So I want you guys to go and have these review questions. Ask yourself this question. Define computer science in your own words, okay? Mention 5 domains within the scope of computer science. And why is computer science considered interdisciplinary, okay? Give 3 examples of how computer science is applied in the real world and explain the difference between software and hardware. So I want you to ask yourself these questions and answer them, okay? Now, you also have a test to write after this class and also an assignment to do, okay? Make sure you do the assignment, make sure you write the test, okay? So, in summary, computer science is more than just computer programming. It is very vast. It is dynamic. Most people think it's just computer programming. No, it's not just that. It is dynamic. It is evolving. It's an evolving discipline that touches nearly every aspect of modern life, from designing algorithms and building applications to solving global problems and creating intelligent systems. Computer science equips people to shape the future with technology. Code your future. All right, you're still in school, year 1, year 2. Use your spare time to build your future. See, your degree is not going to get you anywhere, especially in this Nigerian economy. Your degree is not going to take you anywhere. Take your spare time, continue with whatever you're studying, economics, geography, whatever you're studying, but make sure you're doing this thing on the side. Build this thing up, okay? All right. So thank you very much. I will see you in the next class. Make sure you do your test. Make sure you do your assignment. And if you have any question, please reach out to us. We're always available. Okay. Thank you very much and see you in the next class.